Just wait a few seconds here. And Paul, why don't you go ahead and start?
Good morning. Sorry for the delay. Our topic today is feeds and feeding of pullets and layers, and we're going to get right to it. As an introduction, we have many different ingredients that we can call on to feed birds. I'm going to speak about the nutrients that these ingredients provide, a little more detail about ingredients we can draw on to feed pullets and layers. Then we'll talk about their specific nutrient requirements. And these are like a young adult, a young person versus an older person. The nutrient requirements change with the life cycle of the bird. And then finally, we'll talk about feeding the birds and a little bit about formulation. So as an introduction, feeding birds is both an art and a science. And the science part is the chemistry, the biochemistry, the physiology, understanding the bird and all the nutrients and the chemistry of those nutrients that they provide. The art part is knowing what birds like, knowing the feed form, knowing something about ingredients and their composition, and bringing those two together to make a nice diet for a bird. The unique thing about poultry is we're able to enhance the nutrient profile of the poultry products that we produce. So if we're producing broiler chickens, we can influence the fatty acids and the nutrient levels in the meat. Similarly, for egg layers, we can influence the composition of the egg and the nutrients in the yolk, the color of the yolk, and the vitamins and other important nutrients that are there. So this is a unique feature of poultry that's not as readily done with other livestock and milk products. So let's get on with it. And just to let you know that feed costs are a significant portion of poultry production costs, as much as 60 to 65%. And that's true of broilers and turkeys as well, but it's especially true of laying hens. So here's a figure, a pie graph, showing you some data some years ago, but it's still germane today that feed costs represent about 63% of producing eggs. The housing cost may represent about 16%, and depreciating that pullet cost over the entire period of the production may represent 18%, and then you have other costs as well. But again, feed costs the lion's share of our production costs. Now, I'm going to mention a couple of ingredients, and corn is one. We use a lot of corn in poultry diets, but we also use a lot of corn byproducts. Corn is produced in large amounts in this country for cornstarch because people eat a lot of cornstarch in many different foods. And it's our bane in the United States. We produce a lot of corn oil as well. And the byproducts that are left over after making cornstarch and corn oil include corn gluten meal and many other products. The ethanol industry, for example, in this picture here, represents a significant amount of corn production today. And that's a big factor. And that leads us with distillers' dried grains that are left over after ethanol fabrication. So that's a big thing and amounts to a lot of byproducts that otherwise would be waste products that would end up in landfills and be a huge eyesore and environmental issue. As we compete with corn with other industries like ethanol and other things, that raises the price. And we have seen the price of corn products go up in recent years, and maybe you remember breaking $7 a bushel recently. Soybeans are kind of the same story. Originally, soybeans were produced for soybean oil for human consumption, and that left this byproduct, soybean meal, that we had to deal with. And again, it was a waste product, and it turned out that it was highly nutritious and something that poultry, swine, and other livestock could consume and benefit from greatly. So these byproducts would be mountains of waste were it not for poultry and other livestock consumption. Again, the price of soybean meals has increased in recent years. I think we're looking for a little better price in the year to come, but largely dependent on supply and demand. Similarly, there are a lot of poultry, meat, and fish byproducts that are waste products of producing fish and poultry and meat products for human consumption, animals that are retired from the dairy industry. These byproducts, again, would be a huge eyesore and waste product in our environment were it not for livestock and poultry to consume these. And these include poultry byproduct meals, poultry fat, fish meal, meat and bone meal, tallow, lard, and grease. And all of these have significant nutrients that can be utilized by livestock and poultry. There's also byproducts of wheat milling to make flour and others food waste streams that are still valuable nutrients for livestock and poultry. So let's talk about nutrient requirements. In general, birds eat to satisfy their energy needs. And it's like you and I. When it's cold and we're hungry or we've been working out, we need to eat. We need to replenish those energy stores. And it's largely affected by the environmental conditions of the bird. If the birds are hot, just like when you and I are hot, we tend to eat less and drink more. So therein lies a challenge in summer situations when the temperatures are high to maintain egg production because birds don't like to eat as much as they normally would. Energy consumption is also affected by stress and disease. Animals that are stressed or not utilizing nutrients may increase or decrease their food consumption and energy consumption depending on what they're coping with. We actually changed the density or nutrient concentration of the diets summer versus winter in commercial production because we know birds will eat more in winter. Therefore, we reduce the energy density, the nutrient density, because we know they're consuming more. And in summer, we may increase the density because we know the birds are eating less. So where do we go for nutrient requirements? There's a National Research Council publication called the Minimum Requirements for Poultry, and it includes chickens, ducks, turkeys, layers, geese, pheasant, quail, many different species, but it's only the minimum requirements for birds, and it hasn't been updated in many years. However, there are more current books like the one listed here, Commercial Poultry Production by Leeson and Summers, a really nice book for those that are hoping to learn more about this. And then you can always look to breeder management guides. Let's say you have a highline bird or a Lohman bird, or maybe you buy it from a local hatchery, and these management guides are very specific to the birds you're buying and can be a great guide and with recommendations for nutrient concentrations and diets. So these are all good as well. Let's speak more specifically about the nutrients. There are many nutrients that a bird require, and I've listed them here. Energy is a primary one. The first thing that birds look to when they're looking at food, they need protein, and protein is made up of many building blocks. And these building blocks are called amino acids, and this is what an amino acid looks like. But there's over 22 different amino acids that birds require, and therein lies the challenge. There are essential amino acids, and then there are another group of amino acids that are so essential the bird decided to make them themselves. But there's about 11 essential amino acids that we need to concern ourselves with. In terms of fats, we've got essential fatty acids in linoleic and alpha-linolenic acids. These are both 18-carbon fatty acids. There's about 6 macro minerals that we care about that are essential: calcium, phosphorus, sodium chloride, potassium, and magnesium, and another 6 micro minerals or trace minerals that have to be in the diet. Then we've got our fat-soluble vitamins and our water-soluble vitamins that usually we can put these all into a vitamin and trace mineral pack that's added into the diet and cover these needs. But when I add these all up, it amounts to over 50 nutrients that are needed for the bird on a regular and daily basis. The most important nutrient for the bird is water. And the thumb rule is about 1.5 to 2 times the level of water intake is necessary for feed intake. So if a bird is eating 100 grams of feed a day, she'd need about 200 milliliters or grams of water a day, or 22 pounds of feed per 100 birds. they'd need about 5 to 6 gallons of water per 100 birds. And this is all impacted by the temperature that the birds are exposed to, the production level that the birds are at, and the age of the birds. And I'll show you this in this next figure. Here's showing the daily water consumption of broilers, pullets, and layers, and this is in gallons per 1,000 birds. But let me draw your attention to here, where we talk about pullets. Here at 70 degrees Fahrenheit, we're going to need about 5 gallons of water per 1,000 birds at the first week of life. But when we go to the second week, we've doubled that water consumption. And we go to the fourth week, we're at 1.5 times the level of 2 weeks. So you see how this goes up to 40 gallons by 18 weeks of age as these young birds grow and require more water. Now look at the impact of temperature. Look, we're 1.5 times or more the level of water if the birds are at 90 degrees, which is out of the thermal neutral zone, versus a comfortable temperature of 70 degrees. So you see the impact of temperature here, and the impact of age all through this in terms of water consumption. Now let's consider the impact of production. Here's some layers at a nice comfortable temperature, consuming 40 gallons per 1,000 birds. But when we increase production to 50%, now they need 55 gallons, and we go to 90%, peak production as much as 65 gallons, increasing considerably due to that production level and that moisture that's associated with egg laying. So, some important concepts for water consumption. Water is so essential that you see here the negative impact of water deprivation for only 48 hours. Here a flock is clicking along at 90% production, and for some reason the water is removed or the birds are deprived for only a brief period of time, 48 hours, but look at the lingering effect. This drop in production down to essentially zero, and then how long it takes for those birds to recover from that water deprivation insult, as much as 2 weeks, or almost 3 weeks, I think it counted one day, before they recover to their preliminary egg production rate. And this water deprivation could be because of a broken water system, a well that's went dry, or in winter, very often that will happen when we get freezing and you've not prepared for freezing. A terrific negative impact on the bird. Well, I'd like to next talk about ingredients. Ingredients that we look to for different purposes. And again, let's look at the energy ingredients first. And we look to corn. Corn is really the major cereal, the one we benchmark against that birds really do well on. It has very few problems for birds. The xanthophyll pigment in the corn provides nice pigmentation of yolks or skin pigmentation if we're growing broilers. And even if we have a low bushel weight, the feeding value is still pretty good. The one constraint, and it's not a big deal for layers, is a lot of corn in a diet makes for poor pellet quality. Again, that's not a big deal because most often we're not pelleting layer and pullet diets. One challenge is managing the mycotoxins. These are molds that grow in corn, so proper drying in the fall, proper storage without moisture exposure and contamination are important concepts. But even then, with drought and some bad years, we will have mycotoxins, and you need to be on top of that situation. Another energy ingredient for birds that's used throughout the world is wheat. We don't use as much of it in this country, but it's more common in Europe and other parts of the world. Very high energy, equal to corn. The one challenge is it doesn't have that nice pigmentation, though, that we're used to with corn. The plus side is, though, pellets making pellets with wheat-based diets as little as 10% makes for a good hard pellet. Another constraint with wheat as an ingredient is when we grind it into flour, it makes kind of a pasty gluten protein, and it can paste up around the beak. And then for young birds, it's not very good because it pastes up around the vent or the rear end of the bird and can cause the bird some grief that way. So very fine grind leads to pasty vents and wet litter situation, and that's not a good thing. So a better feed for layers versus young pullets. Some other options for energy ingredients are barley. Has a moderate level of energy. It's used throughout Europe. In the U.S., it might be considered a filler, but for laying hens, an excellent feed for laying hens as well. Another one would be oats. Has even lower energy. It's great horse feed, but maybe not the best poultry feed. I wouldn't recommend oats for baby birds or pullets, but it would be an okay layer feed late in her production when she is looking for more food and we want to dilute the diet and reduce the energy in the diet. It's a great filler for some birds that we're trying to reduce body weight, like breeders that tend to carry too much body weight. We can add some oats, some barleys, basically making more of a diet for them, if you will. And then finally, our most concentrated energy ingredients are fats. And we look to animal fats and vegetable fats that are byproducts that we can look to. Poultry fat from poultry processing, beef tallow, and swine lard are all high energy products that can be recycled and brought into livestock feeds. There are byproduct oils of food production in corn oil, soybean oil, sunflower oil, canola oil. There's even byproduct oils from French fry frying and things like this that can be recycled and reused with good comfort in poultry and livestock diets. The neat thing is the energy level is about 2.25 times the level of energy in the carbohydrates, like the corn, the wheat, and the barley. So very energy dense and brings a lot of oils and fats, bring a lot of other good things to the diet as well. Like flavor, reducing the dustiness, and improves the palatability of these diets. So a lot of features of that, bringing in fats and these energy ingredients to the diet. This is kind of interesting, showing how the price of fat and corn track very closely because both of them are energy ingredients, and it's interesting how they track so similarly in price. And this is corn compared to the fat price. These statistics I got from AgriStats, a company that tracks the poultry industry and performance. Now, let's look to protein ingredients. On the vegetable protein side, we look to soybean meal. Like corn, it's the standard for poultry against which all other vegetable proteins are judged. Corn and soybean meal diets are really good for birds. They cover most of the bases. The one challenge with is maybe a little bit of limiting in the essential amino acid methionine. But we can always supplement that back as a synthetic additive. But corn and soybean meal diets do very well for birds. It is important that we properly treat the soybean meal, and that means cooking it to destroy this trypsin inhibitor. It's an enzyme that's in birds that's essential to, and if we don't destroy this inhibitor with proper cooking, or in the case of roasted soybeans, roasting, it could be a digestive issue for birds. A constraint maximum might be sometimes with very high protein diets or birds that are on the floor exposed to their own feces for a long period of time. High levels of soybean meal can lead to some lesions in their foot pads. But that shouldn't be a problem with cage layers or layers and pullets. Just keep that litter clean and do a good job of maintaining the bedding. But soybean meal are excellent for birds. There are others like corn gluten meal. Again, corn gluten meal is a byproduct of making corn starch, and you end up with this very nutrient-dense, highly pigmented byproduct. About 68% crude protein, concentrated source of xanthophylls and pigments. The only constraint might be slightly deficient in lysine, and maybe it has too much pigment. You can overdo that amount of corn gluten meal in the diet. Another good one that we see a lot of today is canola meal. Comes out of Canada with a great deal of canola oil being produced for people. It generates a lot of byproduct meal. It contains less of the essential amino acid methionine, contains more methionine but less lysine than soybean meal. That's what I wanted to say. It doesn't have as much energy, so that can be a challenge. And for our brown egg layers, there's a compound in there that the birds cannot metabolize that can lead to kind of a fishy flavor, fishy taint to both meat and eggs. So for brown egg layers, I wouldn't recommend the canola meal. And then finally, another source of protein would be the animal byproducts. One that's excellent for birds is actually poultry byproduct meal. It tends to be more consistent because of the raw products that are used in generating it. Poultry processing plants are very efficient machines, if you will, and the uniformity and consistency of those poultry byproduct meals is excellent. The levels of calcium phosphorus, the protein and fatty acid ratios don't vary very much. So they're really uniform, and that works for formulating nutritionists. The challenge is they tend to be very high priced because the pet food industry wants to put the little chicken logo on the dog food or the cat food. So they're competing with us to feed this product, and that usually drives the price up. One challenge with poultry byproduct meal is it tends to be more unsaturated fats, and this leads to greater rancidity. So it's important that these ingredients are stabilized, some kind of a stabilizer is added, an antioxidant is added so they don't go rancid. And then they're good products to go from there. Another animal protein byproduct would be fish meal. Excellent source of protein for birds. We don't use it as much in the United States as it is in other parts of the world like South and Central America. And again, we're competing with the pet food industry, and the price of these may be very high. But birds like fish meal. They do very well on it. It adds to the amino acid profile of the diet. A recommendation might be that we limit it for laying hens to 2 to 3% of the diet. Otherwise, we might get some oxidative problems and some carryover flavors that might influence the flavor of the egg. I'll just tell you a little story. One time I was in England visiting some people over Christmas, and we went out to do some castle viewing for the day on Christmas Eve when we popped a turkey in the oven, and we came back after the day, and the whole house smelled like fish. And I don't know if that turkey was produced and shipped in from Peru or someplace that fed a lot of fish meal, or maybe that animal, that turkey was produced in England but got a lot of fish meal, but it was so heavily laden with this fishy odor that we couldn't eat it, and the dog ate well that Christmas day. So watch that level of inclusion for laying hens. You don't want to end up with fishy flavored eggs. Now, because soybean meal is kind of our base and standard as a protein source, you'll see how closely the price tracks with meat and bone meal. And they go very much hand in hand in terms of formulation of diets. Okay, another major ingredient that we look to for birds are the mineral sources. Birds need calcium, and we look to limestone and oyster shell to provide that calcium in the right particle size for both pullets and laying hens. And then we need some phosphates to provide the phosphorus requirement, and that could be monocalcium phosphate, dicalcium phosphate, rock phosphates, and the like. And then birds need sodium and chloride, so we need some salt in the diet. And then finally, the trace minerals. And there's about 6 different trace minerals that a bird needs on a regular basis, and those can be provided by trace mineral salts, trace minerals added to the diet. And those are the basic ingredients. That's what we need. There are other ingredients that we look to that are essential parts of diets that include the vitamins. That's usually a vitamin pack. Sometimes birds need antibiotics or growth promotants. That's not regularly used with laying hens. Birds that are out on range may need a worming medicine, or pullets reared on range may need that to protect their intestines from the bad bugs that could drill holes in their digestive systems. There are also coccidiostats, and coccidia are like a bacteria without a cell wall that afflict all kinds of birds and other species, and sometimes we need some medicines to take care of that. If you have concentrated numbers of layers, this is an opportunity for flies to reproduce in the manure. So sometimes you can add a larvicide to prevent. It's a medicine that goes in the food or the feed of the birds, and it passes into the manure, and then flies don't reproduce and grow and hatch in the manure, or it reduces the level. Finally, there's preservatives. I mentioned ethoxyquin and other stabilizers that prevent rancidity and give you some shelf life. When you bring feed home from the feed mill, you've got some weeks, maybe a month, before it starts to deteriorate. Now, you've probably heard about probiotics and the positive, good bacteria that are in yogurt and other feeds. Well, these good bacteria benefit poultry as well, and there are products on the market, probiotics that you can buy. A prebiotic is the nutrients that the bacteria grow on. So if I'm adding a lactobacillus, it might be good to add some whey or some other milk-based prebiotics to provide a food for the actual bacteria. So that's a nice combination of prebiotics and probiotics that may do some good to replace the bad bacteria and put good bacteria in the gut that will help the birds utilize the nutrients. And then finally, dietary enzymes. We're using enzymes in our own foods today, and birds can benefit from enzymes and make better use of the ingredients that are in the diet. If we're using more barley and oats and higher fiber ingredients, there are enzymes that help digest those fibers. If we're using peas and unusual legumes, there are enzymes that are designed to better utilize those legumes. So depending on the ingredients, there are good enzymes that can improve the nutrient utilization and actually save money by using maybe lesser priced ingredients, spending a little money on an enzyme, and arriving at the same point in terms of meeting the requirements of the bird. Okay, let's talk about pullets, their feeders and their drinkers. For pullets, we need about 2 inches of trough space per bird, or if we've got feed pans, we'll get about 50 chicks per pan. So if you've got a couple hundred pullet chicks, you may need 4 of those feed pans to do a good job and provide enough feeder space. In terms of drinkers, I really like cups or nipple drinkers. These are very clean systems that the birds don't soil with their own feces or bedding material. And so if you're going to have nipple drinkers, usually you need 1 nipple for 15 chicks. However, if you do have fountains or open type drinkers, the 1 gallon size, which is about a 9-inch diameter fountain, you can usually get about 50 chicks per fountain. If you get the big ones, maybe as many as 150 chicks per fountain. But do clean these fountains on a daily basis, or if you're using trough drinkers, do wash these and clean that drinker every day. And that work is eliminated with the nipple drinker. Dietary objectives for the pullet are pretty straightforward. We're trying to grow this pullet and delay her sexual development until she's ready to lay eggs. And we need that frame to grow and establish a skeleton. And then later in that growth period, we're laying down some fleshing, growing some internal organs, the oviduct, her reproductive tract, to make future eggs. And we have target body weights. If we're talking about single comb white leghorns, SCWL, leghorn type birds, they may weigh between 1,200 and 1,300 grams. If we're talking about sex-linked browns, they could weigh between 1,400 and 1,500 grams. So meeting the exact target is a good thing. So weighing your birds regularly as we follow their development in the pullet house is an important concept. We don't want to overfinish these birds because the fleshy, fatty bird will not reproduce well and produce a lot of eggs. So those are our main goals in rearing that pullet. And it goes hand in hand with the good lighting program that goes with that. We can break the diets for these pullets into different phases of feeding. A starter phase, a grower phase, a developer phase, and a pre-lay phase. And the nutrient density and concentration of nutrients change over the growth of that bird. The baby chick gets the starter feed. It's the most nutrient dense, the highest concentration of fats, proteins, amino acids, and it's like growing children. They need the most groceries, the most nutrients. But as they get older, they need less of these nutrients, and as they reach their target weights and sizes, even less. Okay? Now, in terms of feed form, mostly we feed mash feed or ground feed to birds. However, you can pellet these feeds and crumble them because pellets are usually too big for little baby chicks. But that's an added cost per ton of feed, and mash feed works very well. In terms of feed intake, the single-comb white leghorn might eat between 12 and 13 pounds to get her to the hen house in that 18-week period. The brown egg pullet, it's going to take some more feed, maybe as much as 15 pounds. And these are just guidelines. Different breeds of birds will differ in this amount of feed that you might need. But this will also help you calculate your costs depending on the numbers of birds you intend to raise. Again, the key nutrients for these birds are water, and then the energy, the protein, the amino acids, the minerals, and the vitamins. This is what we care about. Here are some diets for some brown egg pullets. This gives us the specific protein level, energy level, essential amino acids like lysine and methionine here, and calcium and phosphorus. We use one vitamin pack with this concentration of fat-soluble, water-soluble vitamins and trace minerals to get us all the way through this 17-week rearing period. So here's our starter diet from 0 to 5 weeks, a grower diet from 5 to 10 weeks, and these are just guidelines. There are different ones, but you'll see that energy density is decreasing, calcium levels are decreasing, protein is decreasing, and amino acid levels are decreasing because the bird requires less as they reach their target weight. However, in the pre-lay phase, this is just when we light the birds and try to bring on egg production, we may have a little more calcium required. We're trying to lay down some calcium in the medullary bone and prepare that hen to have enough calcium for that first egg. And sometimes the protein and energy levels are increased a little bit. Yeah, here protein goes from 15.5% to 16%, and amino acid density may go up just slightly in the pre-lay phase because this is where we're developing the oviduct and growing those tissues that will generate eggs. So those are the diets we need for the developing pullet. And I got these from this commercial poultry nutrition book, and you too can find that on the internet. Here's some examples of what a chick starter diet may look like. Here's options of different types of diets meeting the same levels of nutrients for the chick starter using either corn, wheat, or sorghum, and then using meat meal or not using meat meal because some may not want an animal product in their diet. So here's a corn diet with some soybean meal and a little bit of wheat middlings, and then another diet that's using wheat shorts, and soybean meal. And then here's another one using a meat meal instead. And then here's one using sorghum, which is less common around here in the Northeast, but is readily available in Texas and other parts of the country. And you'll see the nutrient levels are essentially the same in all these diets by just varying the amounts of these different ingredients. Now we can target our pullet towards different maturity levels and influence some egg parameters. Here, if we light a pullet at a young age, 15 weeks, we might have the same level of production, 92%, but we're going to get more of those eggs early on. And we're going to get a larger number of small eggs and less in that large category. And that could be important to your market. If you want a lot of small and medium eggs, though, that's a quick way to get into production and produce eggs. Now, if we delay that lighting to 18, which is more typical, or maybe even delay it later to 21 weeks, we will hurt our early egg production, but we don't hurt our average egg production because these birds do tend to come back and produce a lot of eggs. And we do get a lot of large eggs, and we'll get more extra large eggs as well. So if large eggs are your market, you might consider delaying lighting to at least 18 or 21 weeks of age. Again, managing egg size for your market. Let's talk about layers. There are different layer feeds, and we'll talk about those, but let's talk about feeders and drinkers first. There's many ways to feed layers. There's hand carts that we can push through the house. Maybe there's trolleys that we can drag around the building and dish out the different amounts of feed for the feeders. There are automatic systems in commercial houses that use pans and carts and cars and chains and augers when you're feeding many, many birds in cage systems. Basically, though, you need about 4 inches of feeder space or trough space per bird. So allow that amount for the different birds. There's many different drinker systems, and here we can have a simple trough drinker or a bell type drinker. There's cups, there's nipples. If you use a trough or some type like that, you need about 3 inches of trough space per bird to allow her space to drink. And if you're using cups or nipples, 1 nipple per 8 birds would be enough to satisfy her need and access to water. Again, I'm very high on the nipples and cups because they're closed drinking systems and aren't as readily contaminated with litter and bedding material, and organisms don't tend to grow in these troughs, unlike the trough systems. So laying hen are our dietary objectives here. These birds are still growing. Even though we moved to the hen house, a leghorn might be about 2.7 pounds, but she's going to lay down another pound of body weight, taking her to about 3.7 pounds. So we still are in a growth phase. So the diets tend to be very nutrient dense for both growth and egg production. Egg production early on will go from 0% to as high as maybe 95%. So you need to cover the nutrients that those eggs are generating and leaving that hen on a daily basis. The bigger the egg size is a factor. If your market is a bigger egg size, you need to plan for that and the nutrients that correspond for that. And the quality of the egg and the egg shell quality are important too. And if you've not provided enough calcium, enough manganese, and enough vitamin D in the diet, you can't expect to have a very good egg shell. That's an important concept. We divide these diets into different phases again, and we might have multiple diets that are our peaking diet or reaching peak production. These diets are our most nutrient dense because, again, the bird is growing and we're reaching our peak production. So the nutritional outlay by the hen on a daily basis is very high. And then after the peak, egg production tends to wane, and it's important that we step back on the nutrition of the bird as well so she doesn't overconsume nutrients, get overfinished, and hurt her production. And then lastly, we may be involved in resting the bird or molting the bird, and there are specific diets for that purpose. You may have birds out on pasture, and the quality of that forage would matter and would influence the amount that you provide in the diet. So that must be taken into account as well. We divide these phases of feeding, again, based on intake, production, egg mass, and the temperature the birds are exposed to. Phase 1 are our peaking diet, and then we have multiple other phases. Feed consumption can vary. Young pullets, 17 pounds up to 20 to 25 or more pounds for brown egg layers per 100 birds per day. So that might help you calculate how much feed you would need for your layer flock. Water consumption is 4 to 5 gallons per 100 bird or 40 to 50 gallons per 1,000 birds. Again, influenced by temperature, stress, health, feed intake, and rate of lay. Now, here's some diet specifications for laying hens. Again, the crude protein, the energy, the calcium, the phosphorus, and the critical amino acids. This vitamin trace mineral concentration would satisfy the requirements of these layers from housing clear up to 70 or more weeks of age. So you'll see over time feed intake increases from maybe 90 grams per 100 birds up to 110 grams per 100 birds. The protein needs of the birds go downhill, 20% down to 15%, and energy requirements reduce, and calcium changes, phosphorus changes, and amino acid density changes over the life of the flock. So this is not static, and it's based on the needs of the bird. Next are some example diets for that phase 1 important diet that gets her into peak production. Again, we've shown diets using corn, using wheat or sorghum, and utilizing meat meal or not utilizing meat meal. Essentially, the concentration of nutrients are the same, just varying the ingredients that we have access and we can use in the diet. This is a nice diagram. It's a little old-fashioned. Production has changed, but it shows what I want it to show. Here's egg production on this axis, and you see at 20 weeks of eggs, egg production is going up very quickly. Today's birds may peak at over 95%, but over the life of the flock, production wanes and diminishes over time. Egg size, however, or egg weight, is small initially. They reach the medium category, and then finally 48 pounds, which is the large egg size, 48 pounds per case. But egg size continues to increase over time if not properly managed, and we end up into the extra large and jumbo category at some point. And then egg mass is just the product of egg weight and egg production, and birds that are producing for the liquid egg market or the dried egg market, we peak in egg mass here, and then that wanes over time as production diminishes too. So this graph shows you where our most nutrient-dense diets need to be. This window right here, from 30 to 40 weeks to 20 weeks, is where we need our most nutrient-dense diets. And then you'll see here that the nutrient requirements of the birds would decline with greater age. The bigger the egg, the greater the chance of shell breakage, because we only have so much calcium to surround that egg. It's like blowing up a balloon. The bigger the egg, the thinner the shell. So manage egg size so that you can optimize that for your market but not hurt shell quality. You can manage egg size by influencing the energy level of diet and the protein level of diet. Energy is important, the fat level, the energy level, but also the linoleic acid level influences egg size. And if you're looking to protein to do the same management tool, you can look at the amino acid methionine. This is some data some years ago looking at a standard protein diet, this green line here, and you see going up into egg size over time, these birds having heavier eggs, larger eggs than the other birds which are on a reduced protein diet, and a lowest protein diet was the blue line, the A line, and you see egg size is much lower. We get into a 48-pound case weight, a 21.8 kilogram case weight at about 30 weeks of age with the normal protein diet. But a lower protein diet, it may take up to 41 weeks or even 51 weeks in the case of the low protein diet. Each protein level and the corresponding amino acid level influence egg size. We care about yolk color. That's influenced by the levels of xanthophyll in the diet. And corn is a great source of pigment, corn gluten meal, but also alfalfa meal. If we have a wheat-based diet, we can replace that level of corn that we might have had in the diet with 1% dehydrated alfalfa meal. That would equal about 20% corn. So if we'd normally have 60% corn and we replace that with wheat and barley, you might need about 3% alfalfa meal to deliver the same type of pigment that you're used to seeing in the diet. And then finally, molting diets. The goal of molting is to take that hen out of production, give her a rest, rebuild the uterus and the shell gland so that she can make a fresh batch of eggs that are going to be high quality. To do this, we need to reduce the body weight of the bird back to her pullet weight. And this is very common in nature. Wild birds, after egg laying, go off feed. I think the example is the recent movie, March of the Penguins. The adults go off feed while they're rearing the chick, and they drop weight. And this is a very normal event. We can molt birds with different types of diet. We can actually withdraw the feed, which may seem a little bit severe, or we can change the nutrient density of the diet so the bird is less inclined to eat as much. With a low sodium, a low calcium, a higher fiber diet, each of these would reduce feed consumption and the birds would go into a molt. Here's kind of the goals of a molting program. We're trying to stretch or depreciate that pullet cost over multiple cycles of egg laying, a first cycle, a rest, and then a second cycle. We're trying to optimize our egg market return. If it's summer and the price of eggs is very poor, this might be a good time to molt your birds or rest your birds. We want to bring that hen back in production if we're molting, bring her back into production at Thanksgiving and Christmas because there's a better price, or Easter because there's a better price for eggs at that time of the year. And lastly, when we rest the bird, we improve egg production when she comes back in the second cycle. We improve shell quality and interior quality as well. Each of these can be improved by resting or molting the bird. So these are our options: a single cycle bird that we may lay out to 85 weeks, or we may have 2 cycles with a rest in the middle, and we would carry that bird out to maybe 105 weeks, or 3 cycles with 2 rests out to 135 weeks. The nice thing about molting is you've got some options here. You're not locked in when you're replacing the birds. Now I can rest those birds over the summer, or rest them just before a peak in market and bring them back into production just for Easter, optimizing our return on the eggs. This is a schedule of molting. Just about 7 days before you would molt, you'd run up the lights to about 24 hours a day. And then when you remove the lights later on here, or reduce the lights down to 12 hours, it's a radical change and the bird perceives something's changing. It's like going into fall or winter and the bird naturally would rest. If you remove feed, you might remove feed for a few days here, or you would put on that molting diet. The goal would be to lose about 20 to 30% in body weight. The bird that wouldn't naturally eat as much, they would lose weight in the wild, and this is the levels of weight loss that you'd see. Then finally, around 3 weeks, we'd start to increase the lights, and we'd put back the complete feed. This is the peaking diet again. We're trying to bring this hen back into production and increasing our lights, and about 6 weeks later, we're up to 50% production. This is an example of some work we did comparing a normal fasted program and the change in body weight, about 1,700 grams down to about 1,300 grams. And in this case, we compared it with a low sodium diet. You'll see the birds did lose body weight, not quite as much, and eventually about 6 weeks later, they are essentially the same body weight. They will recover, and then the egg production takes off in this period here. Again, there's many different feeding programs that you can deliver during a molt with low calcium, higher levels of zinc, higher levels of fiber that will bring about reduced level of consumption.
Paul,
there's a lot of facts.
Just to interrupt you, I finally got back on, but there's a question, do the chickens naturally go through a molt when they go broody? And what about the ethics of molting?
Yeah. If birds are allowed to sit on the nest, there's a cascade of hormones that tend to make that bird go through a molt. She stops that normal egg laying, and she tends to sit on the eggs, and there's hormones associated with that, and then she's in a brooding, rearing phase, if you will. So if you allow your birds to sit on eggs, they will probably go through a molt. And the ethics, I will leave that to the audience. I personally don't have a problem in resting birds because we see it so often in nature. It rejuvenates the birds, and it allows that bird to live through multiple cycles of lay, and we can keep her around for several years. Good. I have one more slide if you want to take the time, just to tell you that we can influence egg size by management, the lighting, the genetics, the temperature, and we can do dietary factors. So I'm just re-emphasizing that energy, fat, linoleic acid levels, higher levels increase egg size, protein and methionine levels influence egg size. So as you make a larger egg, you do make a thinner shell, and you don't want to make a lot of jumbos and extra larges because they might be more readily broken. And then finally, eggshell quality is an important economic factor. If we can't get it out of the hen house and sell it, you've made no money. So again, this is influenced by the genetics, the nutrition, the environment of the hen, her management, and then how we mechanically handle those eggs. Mechanical handling can be an issue, or people that aren't trained to handle eggs on a regular basis may break your eggs. So training your personnel, managing your equipment, properly packaging your equipment, and delivering your eggs properly should yield a better result. And we probably got a minute here for any other questions.
There's a question on, do you recommend a particular commercial brand of feed?
I do not. I think feed should be fairly local. That represents a better price of feed. So check with folks in your area, feed stores that you might, and shop around. There are differences in prices. Read feed labels and choose the nutrient levels that are the right levels for your pullets or your hens. Buy the right feed.
Richard had a question. Because calcium is so important for eggshells, what extra feed should be provided to layers?
Yeah, if you get a complete layer mash, there should be the right amount of calcium. But hens need some large particle calcium, and you can free choice that in the form of oyster shell that could be provided in a little hopper with your coop of birds, or large particle calcium. These are chips of calcium, and these large particles sit in the crop, and because it takes 22 hours to make an eggshell, that calcium slowly dissolves. It's like sucking on sunflower seeds, if you will, and that calcium slowly dissolves into the bloodstream and helps make those eggs over that long 22-hour period of time.
Okay, I just want to point out too that for those that are willing to do so, we have a link to the evaluation form where it says, please fill out a short survey on the webinar. If you click on that, that will take you to the evaluation, and hopefully you'll fill it out for us.
Sorry, we got off to a slow start and we didn't have more time for questions.
Yeah, I had a lot of computer problems at the beginning. Anybody have any last minute questions to ask Paul before we end, because our time is up? There's a few people typing.
There was one on scratch feeds versus complete feeds, if I'll take that minute.
Okay.
Complete feeds are just that. They're complete in every nutrient. When you feed a scratch feed, you're supplementing maybe some pasture or forage that the birds have access to. So we're trying to fill in the blanks, if you will, of what birds may be deriving from the bugs and the soil and the grasses that they're eating. Scratch grains include whole grains, corn and wheat and barley, and maybe some minerals. But it's always good to have a concentrate on the side that if they're not meeting their needs with the pasture and the scratch grains, there's a concentrate that they can supplement their own diet to meet their requirements. I think we're out of time.
Yeah, I think we're out of time. Thank you, everybody. for those that don't know me, since I wasn't on at the beginning, I'm Jackie Jacob. I'm the coordinator for the webinars, and we have more webinars coming up. Tomorrow is one if you do coaching of avian bull teams for 4-H. And the next one in this webinar series is on egg quality under different production systems, and hopefully you will join us for that. All that information is available at extension.org/poultry. Thank you again for joining us. Thank you, Paul, for presenting today.
Oh, you're welcome. Thanks, Jackie.
Okay, thank you, everybody.